Okay guys, so let's get started with the actual coding part for this video. I'm going to make a function that allows you to insert any node into a binary search tree. But before we actually make the insert function, we need a class that actually defines what a node is. So let's go ahead and make that class. And what does a node look like? A node just has a value and it has a left and a right child, correct? Okay guys, so now you guys see that I've described what a node is. So we can use this node class to represent any node in our entire binary search tree. Now we need to actually go about making the insert function, okay? So don't worry about how this code looks for now, just focus on the function itself. Now we have to figure out what actually is going to go into the insert function. How the insert function works is it's going to be a recursive method. The first question is, what are we going to input into the insert function? You're going to put in the new node that you want to actually insert in to the binary search tree. And you also want to give the insert function the node that you're currently starting at. So if you've seen my previous video, which actually talks about the theoretical aspect of inserting a node into a binary search tree, you will know the two steps that I follow. If you haven't seen that video, go ahead and click on the link here or here. I'm not really sure. I'll post it somewhere. The first thing I'm going to do is I'm going to check if a root node actually exists. Because if a root node doesn't exist, then that tree is not existent itself. So if you want to insert your new node, just make it the root node and you're done with that. Okay, so the first thing we'll have to do is we'll have to look at the value that we want to insert into our BST. I'm going to make use of my node class that I made here to actually convert this value that I want to insert into an actual node. The second thing we are to do is we are to make sure that the tree actually exists. It's by checking if a root node is existent or not. So if a root node is not existent, that means the tree doesn't exist itself. So all you have to do is take your new node that you want to insert it and make it the root itself. So let's just do that. So now the question is, what if a root actually exists? If a root exists, you have to start looking at the left and right child. So let's go ahead and start looking at the left child. First thing you'll have to do is you'll have to take your new node and check if it's greater than or less than. So let's go ahead and do that. So if the new node's value is actually lesser than the current node's value that you're looking at, then you would start moving down to its left side. So once you move down to the left side of that particular node, you're going to check if that node is actually existent or not. If there's no node existent in that position, then you can just insert your new node and be done with it. Now, if that position on the left side is not null, you'll have to take the data in your new node and the entire left subtree and then pass it back into your insert function. So right here, we've taken care of the situation where the new node's value is going to be lesser than your current node's value. But what if your new node's value is greater than your current node's value? You will have to start looking at the right subtree instead of the left subtree. So let's go ahead and code that. The code is going to be the same as this, but instead of passing in the left subtree and using the left subtree, we're going to pass in the right subtree. Since you're done with that, this is all an insert function is, and that's the end of it. What I've done here is I just quickly coded up in order traversal method. Like I said, don't have to worry about this too much. I'll show you guys in a completely new video how to traverse a tree. There are three methods: in order, post order, and pre-order. I'll show you guys that completely in a new video. It's a whole new topic on its own. But for now, I have coded this up just so that you guys can see two things. Number one is that the nodes are actually inserted into the tree, binary search tree, and number two is that they're inserted in order. Okay, so let's actually go ahead and run this to see if it actually works. Oh, before that, I actually forgot to tell you guys, I added this part to it. BST, which is a binary search tree, should always have a root node, and because that's what defines what a BST is. And there you go. So that's it for how to insert a node into a binary search tree. I hope you guys like this video. Please give us a like and subscribe.